Summary of my poster for the Strings Conference 2025 based on the classical limit of the sub to the power n leading soft graviton theorems in d equal to 4 without deflection. So let me give a brief introduction. Classical soft theorems are exact statements describing the behavior of the electromagnetic and gravitational waveforms in the low frequency domain of the detector. The most well-known example of the classical soft graviton theorem is the gravitational memory effect, which is an observable of classical scattering and is simply the coefficient of the reading term in the soft expansion of relative field. For a generic gravitational scattering in d equal to 4 space-time dimensions, the relative field has the following form under the soft expansion. So here you see there are three kinds of terms. The first family is just a Lorentz series in Lorentz is the frequency of the detector. The second blue color term represents scalars that scalars omega to the power n log omega to the power n plus 1 capture the infinite set of leading log terms at all orders in a soft expansion. Finally, the red colored of terms that you see here encapsulates the logarithmic terms which for a given n are subleading relative to the corresponding leading log subvectors. And here we mean that the subvectors are universal. By universal, we mean that it is independent of the details of scattering and only depends on linear momenta, angular momenta, and spins of the scattering objects. So what we essentially did is that we computed the leading order classical gravitational radiation in d equal to 4 space-time dimensions, where two massive scalar particles with momenta p1 and p2 scatter at a finite impact parameter b using K-Mossi formalism. K-Mossi formalism is a framework in which you compute classical observables from scattering amplitudes. We then analyzed the soft expansion of this gravitational radiation in b going to infinity limit such that the parameter omega b is fixed because omega tending to 0 and b tending to infinity. So, and we have shown that in this regime, all the terms of the form omega to the power m log omega, where m is greater than 0, greater than equal to 0, survive and can be completely determined by the so-called sub to the power leading soft graviton theorems for tree-level gravitational amplitudes. So, what are these sub to the power leading soft graviton theorems? These theorems reveal the extent to which a gravitational amplitude factorizes when one of the graviton becomes soft compared to other external momenta. For a generic theory of gravity with arbitrary metric coupling, the sub to the power leading soft graviton theorem can be written as the following equation. Here Sn is the sub to the power leading soft factor. The blue color term is the non-universal part of the factorization formula that depends on irrelevant three-point couplings in the theory. For our case, we have bn equal to 0 since we have two scalar particles minimally coupled to gravity. And the red color term is the remainder term that spoils the factorization beyond n equal to 3. So the main question was that how do the higher order tree levels of sub to the power leading soft graviton theorems constrain the gravitational scattering? And the answer is that we showed that the sub to the power leading soft graviton theorems can capture all the log terms in the limit of vanishing deflection or the infinite parameter limit, and the remainder terms never contribute to the same that arises in the classical limit. More in detail, we have shown that the infinite impact parameter limit of the late time gravitational field emitted during a classical scattering can be derived using this factorization theorem. And this is the conclusion that we have seen that the only term that all the omega to the power n log omega terms are captured through this factorization theorem, and the source of such relative modes is the asymptotic interaction between the incoming or outgoing states leading to the emission of gravitational radiation only from t plus minus infinity. As these higher order tree level soft theorems are indicatedly tied to the discovery of W1 plus infinity asymptotic symmetry algebra, our analysis can potentially reveal the link between higher spin asymptotic symmetries and a subset of log terms in the soft expansion of gravitational radiation.